Hi everyone, this is Mrs. Bregner. It is Monday, October 26th, and we had a power outage today. So I'm going to go over the lesson and I'm going to kind of abbreviate it and make it shorter and just make sure that you get all the notes and you're able to do the activity. All right, so I'm showing your at-home lesson. You're going to need your microbiome book and your notes, along with a ruler, a pencil, and a highlighter. Okay, let me show you those right here. I'll bring up my overhead so I can show you. So you're going to need your notes, your microbiome notes, ruler, a highlighter, and a pencil or pen or something to write with. Okay, so go ahead and get those things. Now I'm going to be talking really fast because it is a video and you can pause or rewind at any point in time that you need to. Okay, and we're not going to be able to have the group work that we did in the other classes, but I will go ahead and make sure you have all the information. Okay, so we're going to talk about Bob. He's our patient number 23. And what do we know about him so far? We know that he was fine. And then week 3, he became very sick. He was vomiting, he had diarrhea, and his stomach was really bothering him. So what happened? And we're going to circle back to him later. So we're going to read about 2 arguments about what they think happened to Bob. And you're going to tell me which 2 arguments are better and why. And we're going to learn some vocabulary that goes along with these arguments. So you're going to turn to page 35. I'm going to make this bigger, but it is on page 35 of your microbiomes book. So if you look at the book, you can see there's argument 1 and argument 2. I'm going to read it to you, but you feel free to just go ahead and fast forward and read this yourself if you'd like. Argument 1. Patient 23 felt sick during week 3 because he was infected with the C. jejuni bacteria. From the Human Microbiome article, I know that this kind of C. jejuni infection can cause diarrhea, vomiting, and fever, all the symptoms of food poisoning. These symptoms match the doctor's note for patient 23 for week 3. When patient 23 felt healthy during week 1, the C. jejuni bacteria was not present in his gut microbiome. In week 3, when he felt sick, C. jejuni was present. Therefore, C. jejuni is probably the cause of his sickness. Sounds pretty sound to me. Let's look at argument 2. Patient 23 felt sick during week 3 because he was infected with the C. jejuni bacteria. C. jejuni is very bad for you. He probably ate something spoiled. My sister got food poisoning once. Okay, so think to yourself, which one has a better argument? Argument number 1 or argument number 2? I think we can all agree that argument number 1 has more evidence to support it. And we're going to really talk about how we can break down that evidence. So scientists ask questions and make observations. Then when they think they have an idea about how something works, they make an argument to support that idea. A scientific argument is a way that scientists communicate, evaluate, and revise their explanations about the natural world. So how do you make a scientific argument and how do you support it? So we're going to look at some slides about argumentation resources, okay? And this might look familiar. It kind of is the layout that maybe you use for like some vocabulary or something. But we're going to be looking at it later when we do more Amplify lessons. So I just want to give you an overall of what it's going to look like. And we're going to kind of hit on most of these today. But what is a scientific argument? Well, what is a regular argument? So that's when you have a disagreement, right? Well, for a scientific argument, you're kind of just making your point and you're supporting it with evidence. So we're going to go over what a scientific argument is. We're not going to write it down yet. Give us a minute. So a scientific argument begins with a question, okay, kind of like a hypothesis, and you're going to answer that question. So for Bob, our question would be, why did patient 23 feel sick during week 3? Another question that doesn't have to do with Bob would be, why did the plants on one side of the mountain survive while the plants on the other side died? Yet another is, what is the explanation for why so many people became sick in one city? Maybe not in another. All good questions. All right. Now scientists take this question and they make a claim. Okay, it's kind of like your statement of what you're going to try and prove. So if we review, a scientific argument begins with a question and it has a claim. So our question is, why did patient 23 feel sick during week 3? And our claim is because he was infected with the C. jejuni bacteria. That's our claim. Well, we need evidence to back this up. All right, so here are all the things that a scientific argument does. It begins with a question. It has a claim that proposes an answer. It has evidence, and it supports the evidence with reasoning. So we're going to go ahead. I want you to write this down in your notes. So go in. Let me go exit here. And you're going to bring up your notes. Now, our last page of notes were here, the key concepts. Now we're going to go on to this one, the next page, and you're going to put lesson 6 notes. Okay, lesson 6 notes. Let me make that bigger for you. Nope. And you're just going to copy what it has on the slide. And I'm going to show you the slide in 1 second. I just want to show you the layout. So you're going to say a scientific argument. And then you put the 3 dots, dot, dot, dot. And then you're going to bullet point all the notes here. Okay. Begins with the question, has claim, evidence, blah, blah, blah. So I'm going to switch back to the slide while I copy it down with you. That way you can see it in nice writing. So we already wrote a scientific argument. So your next bullet is begins with the question. Apparently it does not want to load. That's awesome. There. We'll just look at it there. Begins with a question. Has a claim. And we're going to go over these terms in just 1 second. That proposes an answer to the question. And feel free to pause at any time. Has evidence or proof that supports the claim. And last bullet, clearly explains how the evidence supports the claim. That's your reasoning. All right. So you should have that whole slide written down. So mine looks like this. Just has the notes. Feel free to pause if you like. I'm going to keep going on though. So you start with the question, you make a claim based on that question of what you think the answer is, and then you have evidence to support it. Now we're going to draw it. It kind of looks like a tree map, but it functions more like a flow map because I don't think Amplify really understands tree map here. So I'm going to go under my lesson 6 notes here, and I'm going to write scientific argument. Remember, an argument here is not really like a fight argument. It's more like an informational argument. So the first thing you have is a question. And down after the question, like that question is like your hypothesis. You're going to make a claim. And then from the claim, you're going to have evidence. Now, you might have more than 2 pieces of evidence, but we're just going to put 2 here. Now, to support the evidence, how does the evidence prove the claim? You can have reasoning. Reasoning. All right, if you're not done with that, then go ahead and pause the video here. I'm going to keep going on though. All right, so now we're going to go over to the vocabulary. So go ahead and turn to the glossary page in our notes. So So I ended my glossary with bacteria. I don't have any more room. If you have room on your glossary page, then you go ahead and use it. But I don't have any more room. So I'm going to go to the next page. I'm going to do my 2-column notes here. And we have a couple of words to go over. So claim is our first one. So we're going to write that on the left. And what is a claim? It's the answer to the question. And since we're talking about science, it's a question about the natural world. So we're going to put claim. He proposed. Now we're adding this to our 2-column notes. Answer to a question about the natural world. And then I'm going to make a line with my ruler. So I'll show you mine. Of course, it's not as nice as the other one. So I have my claim here, my word and my definition. So I'm just going to go on to the next one right underneath it for the next 2 words. And definitely, if you want to pause, go ahead. Evidence. So we need to support our claim with evidence. So evidence is information about the natural world that is used to support a claim. So it's data, basically. So I'm going to put information, and then I'm going to put in parentheses data about the natural world that is used to support a claim. And then I'm going to make a line. Okay, I'm going to go on to the next one. If you need a pause, go ahead and pause here. And last one is reasoning. The process of making clear how your evidence supports your claim. So how do they relate together? The process of making clear how your evidence supports your claim. All right, so now we're going to go back to the 2 arguments that we read earlier. And we're going to look at them and say, do they have a claim, evidence, and reasoning? Well, if you look at argument 1 and argument 2, they both say patient 23 felt sick during week 3 because he was infected with the C. jejuni bacteria. They both say that, and that's the claim. So they both have a claim, and they're both exactly the same thing. But then argument 1 goes into and cites several things. They sort the article, they sort the doctor's notes, they talk about the graph and how the bacteria was present or not present in the graph during week 1 and week 3. Argument 2 just says, he probably ate something spoiled. My sister got food poisoning once. And that doesn't seem like evidence to me, and definitely no reasoning. So argument 1 really takes the time to go in and support with those details from the article. All right. So poor Bob, he got so sick on week 3, and the doctor prescribed him some antibiotics. What do we know about antibiotics? You probably took antibiotics at some point in your life, right? But how do antibiotics affect the microbiome in our body? So here's the claim. Antibiotics cure infection by killing all types of bacteria in the body, including the harmful ones that cause the infection. So this claim says that it kills both the good and the bad bacteria. Well, prove it. We're going to look at some evidence cards to support this claim. And this is part of your assignment today. So we're going to use what we call the evidence gradient. And I know you guys know what gradient is because you love to include that in your backgrounds when you're working in the Google Docs or the Google Slides or the Google Drawing, a gradient. So it goes from darker to lighter. And in this gradient, we're going to go from the strongest evidence to the weakest evidence. Okay, you're going to go from the strongest to the weakest. And if you were here, I would put you in groups. But you're not here, so I'm going to take you through it now. If you go into, let me go into another tab here, and you're going to go into your classwork assignments. And it is called evidence cards. So you're going to go to your class, go to classwork. You're going to bring up the top one. It says evidence cards. Look, somebody turned it in already, and I haven't even done it with them. All right. So what you're going to do is you're going to read the cards and say, what is my strongest evidence here? I don't really know which one is my strongest evidence. You're going to say, well, it's talking about antibiotics. Because remember, let me go back to this. You're trying to support the claim that antibiotics cure infections by killing all types of bacteria. That's what you're working toward. So if I go to my evidence cards, I'm going to say, I think often doctors treat infections with antibiotics. So the blue one is going to go first. So put your blue one first. Wait a minute. Even though there are so tiny bacteria or living things, that doesn't seem like real evidence about antibiotics. So I'm going to move the green one to last. Now you have to decide which ones go in the middle. In what order? They're usually pretty, I think this one, the orange doesn't seem like the number of bacteria in the microbiome of one human is 1,000,000 times greater than the other ones. That I don't think that really has to do with anything that's antibiotics. So I'm going to put that one down here too. So really it's between the purple and the pink. And I know, wow, that one has a chart. And I remember something that looks like that. To treat harmful infections, antibiotics kill bacteria. Okay, that's what we're talking about, right? After treatment with antibiotics, people have reduced numbers of bacteria. Let's look at the next one. Unfortunately, not all bacteria are helpful. Harmful bacteria can invade the human microbiomes through cuts, spoils food, even the air we breathe. An invasion of harmful bacteria and other microorganisms is called an infection. I'm going to say that the pink one goes next. So let's move it over here. And that means the purple one goes in the middle. Now, I'm giving you guys an answer on this one because we didn't have time to discuss it and you didn't get to work in your groups. So just make sure that you do it in this order. And then when you're finished, go ahead and turn it in. It's like a free 5 points. Woohoo! As long as you watch this video, you really know what to do. So we're going to go pop back. So go ahead and do that assignment and then turn it in and you'll get the 5 points. Let's pop back to our assignment. And now we have our key, what do we call that? We're going to go back to our notes here. And we're going to the key concepts. Antibiotics reduce the number of helpful and harmful bacteria in the microbiome, and that's very important. So I'm going to go to my notes right here under key concepts, the ones we have already started. And I'm just going to make another line right here. And I'm going to say antibiotics reduce the number of helpful and harmful bacteria in the microbiome. It doesn't say human microbiome, but it is assumed. All right, I'm going to put you back on the Google Slides because it's much neater here. So just make sure you have that written down. All right, so Bob, he got our antibiotics for his infection. I wonder if they worked. So in our next lessons, we're going to see what did the antibiotics do to the bacteria in Bob's gut, and did he get better? Because remember, we saw him on week 3, and it did say he took 9 weeks to get cured. So you'll have to stay tuned for our next lesson. So just make sure you go ahead and turn in that assignment on your evidence cards, and you are good to go. Bye.